Number 3. A bare helium nucleus has 2 positive charges and a mass of 6.64 times 10 to the minus 27 kilograms. Letter A. Calculate its kinetic energy in joules at 2% of the speed of light. Okay, so first of all, what is 2% of the speed of light? What would that speed be? Well, you gotta know what the speed of light is, right? It's about 3 times 10 to the 8 meters per second. And then what's 2% of this? What we gotta do is take it, multiply it by 0.02. And what do we get? So take out the calculator, 3 times 10 to the 8, 10.02, right? And it comes out to be about 6 times 10 to the, should we count or should we just do the math in our head? What do you think? 6. Cool. Meters per second. So this is indeed the velocity, right, of 2%, or this is the velocity of 2% of the speed of light. So now they want us to take this velocity basically and calculate the kinetic energy, okay, of a bare helium nucleus that has 2 positive charges, and it tells us the mass, the 6.64 times 10 to the minus 27. So what is then the kinetic energy formula? Simply kinetic energy is equal to 1/2 times mass times velocity squared. So the kinetic energy therefore will be 1/2 times the mass of that particle that's moving, which is the bare helium nucleus, which is going to be 6.64 times 10 to the minus 27 kilograms, and then multiplied by the velocity 6 times 10 to the 6 now. And what do we get? Let's see. Oh, whoa. Almost forgot to swear it. Did you catch me on that? I hope you did. Just seeing if you're paying attention. 6.64 times 10 to the minus 27th, and then multiplied by that value squared. Okay. So I get a value of about 1.20, I guess, times 10 to the negative 13th, and that's in joules, okay? Now, calculation in joules. Okay, great. So letter A is finished. All right, now let's take a look at letter B. So why don't we change the color? All right. So what is this in electron volts? Okay. So you have to know the conversion here, and you'll probably be doing so many problems that you should memorize it. So the basic idea is that 1 electron volt, 1 eV, is going to be equal to 1.6 times 10 to the minus 19th joules. You might also notice that, boy, does that number look familiar? Right, that's also the charge of a proton, the charge of an electron in coulombs, okay? So how do we now do a conversion? We'll take the value of 1.20 times 10 to the minus 13th joules and set it up. Joules on the bottom, electron volts on the top. So for every 1 electron volt, it is 1.6 times 10 to the minus 19th joules. Joules cancel, see you later. And then do your division. Okay, so divide that now by 1.6 times 10 to the minus 19th. And here we get a value about 7.47 times 10 to the 345. And that is in terms of electron volts. Now, yeah, 3 sig figs looks fine. Okay, let's take a look at now letter C. So it says then what voltage would need to be, would be needed to obtain this energy. So as soon as I start seeing like voltage and energy, I start thinking about, well, how are they related formulaically? And they are related formulaically by the following formula. It's on the top, well, it's middle right here on the screen. But it's basically that the change in potential, or the voltage difference between 2 points, is going to be equal to the change in potential energy of the object, or the particle that is in that potential difference, divided then by the charge of that particle. Okay, so what that means is that in order to find voltage, we would need to know the change of potential energy and the charge. So here's the thing. Do we know potential energy? Turns out that we do. We do know potential energy. You have to remember that the basic idea here in terms of conservation of energy, it's very, very important. We've done this for the past couple problems now, is that, essentially, unless stated otherwise, whatever the kinetic energy of the object is, that came from then the potential energy of that particle in the electric field. Check out number 2. I kind of went into a little more detail on it. All right? Not to belabor the point, but let's just show the calculation here. So the voltage difference is what we're solving for. The potential energy difference is going to be the same as then the kinetic energy that this particle obtained, or was able to obtain. All right? So this is 1.20 times 10 to the minus 13th. And then divide that now by the charge. And what does it tell us the charge of it is? Well, it says it has 2 positive charges. What's the charge value of a proton then, of a positive charge? It's 1.6 times 10 to the minus 19th. But how many of them do you have? 2. So just take it and multiply by 2. That's all. And let's do the math. So I'm going to use the exact value from before, the 1.1952 times 10 to the minus 13th. And then take that and divide it by 1.6. I better make sure I get parentheses here. 1.6 times 10 to the minus 19th. And then multiply that by 2. And we get a value of about 3.74, considering the rounding, right? 3.74 times 10 to the 5th. And that is then in volts. Okay? And voila. Guys, thank you so very much for tuning in. We appreciate it very much. Please help us out and subscribe. Tell your friends. Hit the like button. Smash the like button. Mutilate it. Destroy it. I don't know. Whatever they start saying nowadays. You know what I mean? Beat the bejesus out of it. Sure. If you're still listening to this rant, God bless you. Take care.